Nowadays, a lot of people are talking about digital transformation. And actually today we'll show you a concrete case of digital transformation where a very large billion-dollar company, Legal & General in UK, has been using us to migrate a very critical application, a risk evaluation in finance, onto the cloud, and actually onto the Azure Cloud. So we will see at the end that actually we get incredible acceleration in the execution of the application, migrating from on-premises to the Azure Cloud, and also saving on the resources. So I will give a brief introduction, and then we will continue with concrete information about the use case. So ActiveEon is proposing a solution that actually goes from building automation workflow. This is it here at the top. A second part is scheduling and orchestration, and the third part is resource management and monitoring. So the workflow themselves allows you to build parallel and distributed execution. So you can actually specify that you want to execute this task 10,000 times on 10,000 different distributed resources. The second part is a multi-user, multi-application, multi-tenant scheduler and orchestrator that will apply different priorities to the corporate scheduling and orchestration. And usually most of the schedulers will stop here and relied on external provisioning of resources. With ActiveEon solution, we actually have a building resource manager, which allows you to provision, deprovision, manage elasticity, and we'll see in the concrete case here, we will be able to actually allocate tasks to resources based on memory consumption or I/O or CPU and so on. So why is it important, and especially in a cloud migration framework? I mean, when you execute on-premise, you have your own resources. When you move to the cloud, you don't have your resources, you pay per the hour. So it's getting very important that you actually optimize the usage of your resources. And this is what we are doing in this diagram. So we are actually compacting the execution, making it more efficient and faster to get a faster result and to do more with less resources in a smaller time. So we'll move to the concrete case of Solvency portfolio risk calculation. And I will let Guido explain what he has achieved in this migration.
Thank you. So at Legal & General, we have the need to calculate the value of all of our financial instruments. Think about bonds, securities, but also mortgages and bank retirement funds, etc., under stress. What does it mean? It means how much money are we going to lose under hypothetical market conditions. So we need to change market conditions to hypothetical ones and recalculate the value of all of our portfolios. And this needs to happen 2 million times. And it's a massive computation that so far takes, I believe the latest timing is 3,000 hours of CPU. So it is imperative to parallelize it using a computing grid. So one of the biggest problems we have is that we have some tasks that are heavily CPU intensive, and it uses the CPU 100% for, again, 3,000 plus hours. On the other side, we have running in parallel with that tasks that are heavily I/O intensive that need to do about 2 terabytes worth of I/O within an 8-hour period. So what a solution we came up together with Proactive is to run the same some CPU-intensive tasks in parallel with I/O tasks on the same hosts, so that every single host is slightly overloaded, but in the end, you end up a much higher throughput and you don't waste your time. So you have one task that is stuck on I/O for minutes, and another task that is consuming the CPU resources of the same host. And that way, in the end, the overall throughput is maximized and we are not wasting any time, we are not wasting any hardware resources. We pay for hosts per minute. So whether a host is busy on CPU, we pay X. If a host is busy on I/O, we also pay the same amount. If the host is busy on both, we pay the same amount. So we're effectively halving the amount of money we spend and the time it takes to do the same things. This is a graph of our batch. This is, again, it used to be in the beginning an 18 hours batch, and it is running in proactive. And every box you see is a task. We have 3,000 something tasks that are breaking down the problem into elementary units, and we just submit them all at once to proactive, and then proactive handles scheduling those tasks along the grid. Here you have an example with 31 hosts on the grid. That was our previous grid that was on premises, so hosts that were permanently up, owned by us, incredibly expensive. And you can see already in here the pipelining of the CPU intensive tasks, which here are colored in the purple, blue, and green, with the I/O intensive tasks, which are colored in yellow, that are running at the same time on the same hosts. And another big achievement we got with proactive is that the first third about of the tasks produces the most important results. So we devised a way to run all the most important tasks at the beginning and push out to our final users, our consumers, the most important reports ahead of the end of the batch. And since the whole batch takes 18 hours, but the most important reports are out and ready to be consumed under just 5 hours, because we really don't want to wait for the end of everything to start reading out the results. This is the batch today. So this was about 1 year ago. This is the batch today. We have migrated to Azure. We are now running a grid that scales up and down on the fly. On the left side of this graph, you see how the batch starts timidly on only one host, and then the batch schedules 1,000+ tasks on proactive. And the grid automatically goes up to life. All of those 64 computation hosts were completely shut down. We were not paying for them. The moment we need them, they go up. 15 minutes later or so, we're still trimming the performance. You see that proactive looks up the nodes, registers them, and starts running tasks on them. And at the end of the batch, the node goes down again. So here we have a 5 hours batch. We paid exactly for those 5 hours, not a penny more. There is another interesting bit in this graph that you can see. You see that white area towards the bottom right. Now that is a host that died in the middle of the batch. Don't know what, hardware failure, something, kernel panic, don't care. The most important bit, however, is that proactive noticed, routed around it, and just moved the tasks that were designed for that host somewhere else. And the batch proceeded to completion without a glitch, just very slightly slower. And now, again, we started on an 18 hours batch. Now, thanks to proactive and thanks to additional optimizations we did along the way, and thanks to Azure, it's now down to 5 hours. And by the end of the year, my hope and expectation is to go definitely below 4 hours, and possibly less by adding more grid hosts, more capacity to the grid.